this one, and hello, hello, hello. Okay, so this is my lovely microphone. Yeah, this will obviously be a better. I'm peeking there. This will obviously be a better microphone than this one. Just going by size. Yeah, if I switch to a scene that doesn't have it now, let me know. That mic is better. Yeah, it is better, but the reason I've started to even look at something like this is turn off there. I have been recording more videos on my DSLR, and I am. Let me just turn this off. Oh. Give me 2 seconds. Testing, testing, 1, 2, 1, 2. Testing, testing, 1, 2. How is this and interference and things like that? We are on the small mic again. Yeah. The problem was I didn't have the cable plugged in right on the receiver. So let's there's still interference. Okay. That I can't imagine that interference will be there when I'm actually recording stuff. I must listen back to that. We'll go back to this one. But okay, so this is better at least, but it's just not as good as that one. That's fine. But grounding what? Like there's no I don't have any like analog. I don't have any analog input into this system. Like the receivers run on battery. The camera is now running on a battery. Like what do you ground? Okay, we're back on the good one anyways. Oh, we're possibly on both. Okay, should be gone now. Okay. Right, let's do some soldering. So this is from Chris. He sells these on Tindy. It is a small I2S microphone. Touch the ground of the battery. Yeah. Yeah. Where is my solder? Here's my solder. My TS80P has gone back to sleep. He's like, Brian, you turned me on ages ago and I'm not ready. Can I turn down the brightness of me? Configure video. White balance. Whatever you're doing for white balance isn't great. Camera control. Your exposure automatic, and that's what you give me. It's kind of grainy when I go down there. Gain. I'm pretty sure I don't need gain. Okay. That's probably more representative of what I look like. Okay, let's go. Let's get his way in here. Let's focus up. Okay, awesome. Right. My main source of light is to my right, and I'm holding my soldering iron in my right hand, like creating shadows, but that's just what we're gonna have to do. Okay, so I'm gonna solder 1 and then kind of straighten it up a bit. No, shouldn't have soldered ground first, but we are where we are. Okay. You see, I'm absolutely miles away from where I want to solder now, so I have to lean forward, so I'm like leaning out of frame to solder. Could move my webcam, I suppose, but that's neither here nor there. Okay. That. Oh no! I've like put all this effort into getting like this nice top-down view using my digital SLR, and then I put my face cam in the way of the actual soldering. Okay, yeah, so I don't know if we'll be able to. Yeah, we really are at the limit of what I can focus on when focus. It's just progressively getting worse. There. I'll have to figure out this side of things. Okay, seems like I can do a bit of focusing with the screen, but then you see what's on the screen. Right, so that's fine, that's soldered. Right, so the next step in my plan for world domination is, let's zoom out, do a bit of focusing. Next step in my plan is to connect this microphone to the Trinity. Right, so if you don't know, the Trinity is a ESP32 board that I'm making that's for controlling these Hub 75 matrix panels. I'm sure you all know this at this stage because I've been harping on about them. Yeah, so unfortunately we can't just drop this into the spot. That would be delightful, but we can't do that, so we'll have to use jumpers, which is fine, but also it's the worst thing ever. Yeah, the table one was my focus rather than my face one. We'll work on that some other time. See, the other problem I have as well is that this is not my permanent office, so I'm kind of reluctant to do anything too major to it in terms of. I don't need this last one, I guess. Cheers, Frank. I'll take a look. Well, probably when I finish the stream, I'll probably go to bed, but I will take a look in the morning. Thank you. Now, I don't plan to be streaming late, but I say that literally every time, but I'm not going to stream late. I didn't even tell my wife I was streaming. I just locked my door in case the kids try to come in, which they have been known to do in the past. Okay, that's them plugged in. Alright, so how zoomed in can I get on this focus wise? Okay, I really need to figure this out. Oh, you had it there. Right, so we've got ground, VDD, source clock. Actually, we can go straight to his documentation. Just move my. Because this will be easier to focus on than that. Okay, so that is not in pin order, actually. The bottom one is ground, which is obviously ground. So for me, that is kind of red, which is H G7. G7. Lumix G7. GH7? Jeez. That one. The cheap Lumix one is what it is. It's a big step up from the webcams, but yeah, still need to use it. Figure out how to use it properly. Okay, so that's ground and VCC plugged in, so there's kind of add-on pins over here. Now this is where we'll have to vary a little bit because I don't have any of these pins here, but I think we can use any of pins we want. But one thing that may be a problem, and I have no idea what the solution is to it, is the matrix board uses I2S to interface with the matrix board, as far as I know. Makes use of the I2S peripheral at least. So how this will work, I know there's two, so maybe it's okay. Maybe it only uses one, maybe it uses two. I actually don't know the answer to that question. But I guess we'll find out. But before we do anything with the matrix panel, we'll try to get it working like on the serial monitor first. Okay, so I don't see why we can't just connect these to random pins and see what happens. If anyone disagrees, speak now or forever hold your peace. So source clock will plug into SCL, why not? SD, which is serial data, will plug into SDA, why not? And then WS, which is left-right clock, I'm going to plug into pin 32. Okay, so we have everything plugged in there. Very nice. I don't know. Literally, I have never personally used I2S in a sketch. Like, as in, obviously, the matrix library makes use of it. I don't know. So this is an interesting problem I have now of the webcam, is that, or sorry, of this. Like with the webcam, I could have kind of like adjusted G somehow to get it pointing towards the matrix panel. It's just not really an option on the DSLR. So although I won't be showing the matrix for a little bit anyways, but I suppose I can I still have my webcam here, so I can potentially properties deactivate activate. No, maybe it's deactivating the wrong one. C920 deactivate, activate. Okay. We do have my old webcam here, so that is still a potential possibility for these desk style shots or whatever. I need to jig around with the scenes a little bit though. Okay, so LG monitor share. Let's get me in here, because you need to see my lovely face. Me webcam. Oh. Yeah, Rotor. You came here looking for answers. You came to the wrong place. Yeah, I normally go, oh, I don't know if I can do something, and Rotor goes, oh yeah, you can. And I go, oh, thanks. That is how our relationship works. He's probably off looking up the answer right now. Okay, so let's get atomic 14. I will move it over in 2 seconds now. Okay. Alright, where is my OBS so I can see what you're seeing? Okay, that's pretty good. Yeah, so he has a TFT audio monitor. This is Atomic 14 still. Okay, the first thing we should do is he has one here called ESP32 I2S mic test. I feel like this is kind of a Hello World style one, so let's do this. Okay, do I need to install any libraries or anything? I don't think so. What even do I have? It's the 434. It's this one. Feel free to change the pins, but make sure to adjust. You should see a waveform like this if you whistle. If you can't whistle, try screaming. Fair enough. Okay, so let's just grab this. It seems like we don't need anything other than that. Okay. Yeah, I've never used it either. 200 to 250. Well, I am voice over Telegram. Oh yeah, you could potentially do that. Yeah, I don't. My lens is 25 centimeters above my desk at the moment. So that taller one might be useful. Yeah, you could potentially send voice data over Telegram. I think the use case would have to be something more like I heard a noise. Here's what I heard type of device. It would. Am I done with the YouTube chat library? I'm not fully done with it. Is there a more specific question? Like, I don't believe I have the callback changes merged into the main branch, and they will be merged in, but I still have some tidying up to do with that. And I have to improve the examples with the library too. See ya, the embedded hobbyist. Intrigued by it's not very good. The quality of audio you get from them, like, it's fine. Yeah, Atomic 14 has loads of videos about the I2S stuff, and he demonstrates it fairly regularly, including like playing back the audio in, using raw captures and then converting them using Audacity. Hey, Sion. Yeah, the callback stuff is in a second branch, if I'm not mistaken. Yeah, I'm really impressed with the callback stuff. That's working great. Let's look at this raw. Raw. What do I need to do now? Open the Arduino IDE, I suppose, would help. Let's move that over there in case I open something I shouldn't. Arduino.exe. You are so clever. What are we looking at here? Still my desk. Okay, so let's open a new sketch. We have gathered all the code. Let's paste that in here. Right, serial clock was, oh. What? I think this has to be a mistake, right? Ooh, retracted. An equalizer matrix. An audio equalizer on a matrix? Equalizer is the right term, right? For the thing that like bounces up and down to the music, right? I think so. A lot of blinking LEDs. This is wrong, right? Are you zoomed in enough to see that, or movie here? Like this should not have an underscore, right? It should be I2S mic serial clock GPIO num 32. Yeah, yeah, that's exactly it. Software audio equalizer on the matrix. On an LED matrix. Yeah, that might be clear. Might not be clear. Don't mess around with this. So I2S serial clock. Oh, GPIO num 32. Why does he do that? Why would you do that over just saying 32? I suppose it makes sense on a ESP. I didn't see this space. It makes sense on like an ESP8266 with the D1 minis have their own like numbering system. So when you use D1 or whatever, that is a macro. Yeah. I'm gonna make it kind of bad too because I'm gonna use SCL, which is also a macro, because I don't remember what the SCL pin is. SDA, and oh no, that's not it. Left, right. This one's SDA, and this one is pin 30. But I don't think the same 32 D32 thing exists on ESP32s. Okay, that should be good. Let's get my cable. Plug it into the Trinity. Let's get rid of diode bypass because I have no idea what's running on this. No idea what's running on this Trinity, so let's not try power it over USB. COM7 probably. Yeah, that should be fine. Let's upload that and see what happens. It's asking me to save the sketch. I2S mic test, I suppose. Okay, so it's compiling now. So what's everyone up to? Tell me what's going on. Let me live my life through you guys. I spent the majority of the day building a treehouse type thing for my kids. It is not finished, but I will hopefully finish it tomorrow. This chip is an ESP8266. Well, I'm sorry. It's obviously COM4, so. Yeah, there was just a couple of things that I wanted to test. I'm up to doing the best version of me being sick in like 30 years. Yeah, you're like a machine, Sion. You're like the Energizer Bunny, you keep going. Been repairing solar garden lights all day for my mom. Nice. We need to get a few more of them. Climbed a mountain and had a burrito. In that order? Was there... I'm not sure. Are you in Australia? No, you couldn't be if you climbed a mountain today. Your today only started like 2 seconds ago. Eating pudding and watching YouTube. Well, I'm glad I can provide some entertainment for your pudding. Okay, so it's doing something. So what do you have to do to change this into tools? Is it serial plotter? Okay. It seems to be doing something. Can you see that? You can. Okay. Testing, 1, 2. Testing, 1, 2. Yeah, what's kind of weird is like the keys, or sorry, what is that term called? The range of the graph changes like a huge amount. So when I'm not saying anything, like it's bouncing all around the place, but then the range completely changes it. I'm going to do whatever Chris did, Unexpected Maker, because he has done this project, but just not on a matrix. The log scale, the lock scale, the LOUGH scale, the lock scale. Yeah. Okay, so the microphone works. Okay. Hello world, done. So now comes the fun part of we have to actually get some code working. Okay, so back to Chris. We're raiding Chris here. What's CC10? Creative Commons. Should be fine. Yeah, it's that top one I think makes the most sense. Seems like it was updated 9 days ago too. Ship it, get it out door, done. Yeah, so this is what I want to do, but on a matrix. This will get the TFT library as well. I don't really need to worry about that. So I need to see what he's doing and hoping it's not too bad. Right, so he uses what's that thing called? Platform IO. What time is it here? It is 11 o'clock at night. He uses Platform IO, so that makes it a little bit more complicated for us to use an Arduino, but I think we'll be okay. We should just be able to add these as like additional files. Audio processing, because he has it all separated, like we should be okay to be able to just drop 2250 says it says 58 on my computer, Johnny, just throwing that out there, but the 22 is correct. We're in the right hour zone with that Hamming window. Yeah, Hamming window makes sense to me. You gotta have a Hamming window. Yeah, he has keeping it simple, fast Fourier transform .h. Okay, so he has where is he getting that from? Tools slash. Okay, where am I getting tools from? Oh, here. Okay, so we might have to. It might be easier for us to diverge from what Chris is doing, because people have done this for Arduinos too. So I know, is it Squix? ESP32 graphic, graphic equalizer, is it I2S? I could have searched for that terribly. I2S mic display. I think man's name is Squix. Yeah. Let's skip all the work. So yeah, he uses like the fast Fourier transform Arduino library. I'm down with that. Like, I'm gonna let you all in on a little secret. This doesn't have to be good. It just needs to move, right? Like, it can be improved down the line, but like the goal for me would be like, if it works, that's it. That's the goal. Like, it can't just move randomly. It has to respond to the music or whatever. But like, it doesn't have to be that good. Pretty bouncing bars. That's the goal. Just bounce, bounce, bounce. Do a nice little animation where, you know, the peak thing falls back down to the bar. Mwah. That's the goal. Nothing good. Just good enough. Right. So let's go to libraries. Manage libraries. Let it load for 1,000,000 hours. It's so slow. Hey Rob, by the way, how's it going? It's party time in Sackland. Everybody wanna have Sack. FFT, fast Fourier transform, FFT. Arduino's, oh, I've already installed this. Okay. This is obviously a path I've been down before, but I don't think I was down this path on the record. Well, what does he do? He sample data from the microphone. You need a buffer to. Can I just go to his finished code? So if you don't know the Squix 78 guy, he does a lot of cool stuff. I think he mainly works on his blog, and he sells stuff from I think his shop is called Thing Pulse, or like that's his kind of company. It's worth checking out for sure. Yeah, let's get some random code. We are going to not do the WebSocket stuff. That much I know I don't want to do. But see, like here, he's already serial printing data. He's just not doing this anymore. For whatever reason. Like I'm guessing that's, you know, testing. I would say get data is a bad name for what this function does, but that's fine. Okay, this is what we want. Driver I2S. We have this installed, and we don't need any of the Wi-Fi stuff. Okay, so let's start from here, and we will leave his headers and stuff in it for the moment, anyways. Okay, cool. Let's throw some random code in. Oh yeah, filtering out the bejesus out of it is useful for getting the voltage spikes and shaving off the details. Sounds good to me. Okay, so we don't want WebSocket, web server, or Wi-Fi. None of that, please. Code by Squix. Original code by Squix. original code by Squix. Brian removed Wi-Fi stuff. Okay. Labels, that's fine. Let's get rid of connecting to my internet. Let's get rid of the web server. Let's get rid of the WebSocket server. Yes, I like this trick too. The putting the web page in a string literal means you have to escape way less stuff. I'm pretty sure I have a video about that somewhere. I suppose I could have kept this and we could have ran his demo, but that's not what we're after. It's not what we're after. Okay, so that's fine. Setup mic. We'll have to change that. That's fine. So source clock was SCL. That was 33, and data in, I'm guessing, is SDA. Such lofty goals. You know me. I do actually want to. I genuinely don't want this stream to go on all that long, so I'm cutting stuff out of my life. Let's get rid of all that Wi-Fi stuff. Let's get rid of server stuff. Let's get rid of this stuff. So he's just reading and doing the fast Fourier transforms as fast as he can. Let's get rid of get data. Don't want it. Let's put this back in. See what that looks like, and we can get rid of the stuff. Guys, programming's easy. You just come in and you just hack away everything till it's gone. We don't even know if it runs, but I don't know what to call this. FFT ESP32. Okay, cool. You just get rid of everything till it's gone. Will it compile? Who knows? This was worse than copy and paste programming. This was hack and slash programming, where we're just hacking everything out. Just chop. Straight to jail. Done uploading. That was fast. Wow, the Trinity is such a high quality board. That has such high quality... What's this doing? Such high quality components that it can upload so fast. Compile and publish. Job done. Right, take them away, boys. Except I don't see anything on the serial monitor. This should happen a lot, but I'm not seeing it. Oh, did I start the serial print? No. Did I? Oh, I hacked too much away, guys. As Bitlooney would say. Guys, we broke it. 11, is it 11,500? 11,500? I actually can't remember. 11,500. 11,500. Okay, perfect. Do you notice, like, Bitlooney, he always, like, when there's a problem, it's always, guys, we did this. But when things are working, he's like, I did this. That's not true, but it feels like it is. He's really made some progress with that PoE board over the last week. Com4. Okay. Well, that's something. Okay. I don't know what this represents. Ship it. Done. Okay. We might have to look at the web code that I just deleted to see what these numbers represented. Let's go back to the GitHub. Okay, so he just put the band value straight into JSON. Okay, so that's fine. A label, code complete, boom. He put the whole string into JSON. Okay, so now let's go up and look at the web code and see what the WebSocket did with that. Okay, so it had a max value. The max... What's a max low? Okay. Okay, so on message, he receives the message. He just clears out all the values. He gets mat min, which is max low, or element def value, whichever is lower. And then he pushes that to low. And he pushes that to high. I'm not following this. So he's been labels. So he's a JSON array of, it contains a single value. Hey Chris, stream health looks okay to me. I don't have any drop frames or anything. Maybe the graph out only one of the bars. Yeah, I guess that makes sense. So we just start with one. See what happens. Which one should we start with? Which is the best one? 125. I kind of feel like it'll probably be as easy to do them all. We'll see. How many bars does he have? 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Number 3. I can say 3. The bass. I don't know which one is the bass. The lowest frequency, right? 125. I'll have to start talking like this. I'm just trying to figure out what he's doing to graph stuff. Data plot, get element by chart. Right, so that's a canvas. Data plot dot data, data set 2. Let's maybe look at the demo again. Low, moderate, high. Okay, so these are the data sets, right? Mat max. So whichever is the minimum. Okay, so element value minus low value. Okay, so these 3 different ones here are the red, green, and blue stuff. Or sorry, red, green, and blue. Green, yellow, and red stuff. So like it only gets down to this next. It only gets down to this next thing if it's over a certain threshold. So like this mat min stuff like works fine. It's a little bit hard to follow. Like I kind of feel like if it's less than whatever be green would be okay. So we might change that up a little bit. But he seems to just be graphing the stuff. So I think the next thing, he has 8 different ones. He has 3 different colors. Can you see that? Yeah. So these are the 3 different colors, and he's basically just like going like if using the mat.min or matmin and matmax and stuff, he's basically getting the yellow value, like if I'm above green, basically, how high above green am I? But he's kind of clamping it then at 1400. So anything above that would be red then. The next thing that I want to test actually is not that. I want to test, does it work with the matrix? Even before we start drawing stuff. I'm so mad right now. My kryptonite. That silly little phrase. I'm just gonna go look at my lovely desk for a minute. That's how mad I am. I want to do hello world. Is that here? Don't know where hello world is. Should be just called hello matrix. But anyways, let's open it up. Open. That's true. Yeah, we've been chatting a good while now, Sian. It must be 3 years, damn it. It has to be about that. It's a what do we want to call this? What's the thing called? Anthony Clark. How's it going, Anthony? Great to see you made this top of my to-do list. I got a microphone and I was like, rather than put this away, I might actually try get this to work. What's the name of my shield? The I2S matrix shield. That's what I'm looking for. I2S matrix shield. ESP32 I2S matrix shield. Examples. Text. Hello world. Yeah. So I actually kind of have an interesting problem with the Trinity as well. I've started to build up like a really good like array of examples and stuff, and on the I2S matrix shield, which is effectively the same thing as the Trinity. And I kind of don't know what to do with the examples. Like, do I like modify the I2S matrix repo to now be the Trinity repo too? You know, I don't want to maintain both versions of the, like, they're literally the same in terms of code wise. Like, you can do, like, one piece of code will write the same to both of them. So yeah, I'm not 100% sure what I want to do with that. Okay, so here is the most basic of examples, which I think will be easier to put into... No, I can't use the most basic of examples. I need to use something else. 1 second. And I'll explain in a second. I need to kind of combine another example into this as well. Okay. Alright, let's add the matrix library in. What are you looking at the moment? My lovely desk. Okay, here. Okay, let's add the matrix library in. I will do my fancy thing, and I'll do this at some stage. Dependency libraries. Okay. Now, matrix config. Let's throw this in here too. Do any of you have the I2S matrix shield? Out of curiosity. I can't really see at the moment. Let me change that. Okay, cool. Yeah, do any of you have the I2S matrix shield? Because I need to update my examples because the library has changed recently and it was changed for the better, but I need to update all my examples because of it. But so normally you would just define DMA display here or set up a new one. But the new way you do things is you put a placeholder pointer there, then down in your setup, after you begin your serial monitor, you put in your config stuff. And for me, so we're not going to use the double buffer yet, just because it's easier. But you now don't need to modify the library anymore to change some stuff in it, like the resolution of it and things like that. So like you can set pin 18 from here, you can set the resolution. So this is a really good change because it makes your code a lot more kind of portable, although your code was plenty portable before because you couldn't actually set the 64 by 64, but now you can, like, you know, you don't have to change the library in between writing to a 64 by 32 one and a 64 by 64 one. And also there's some kind of like kind of flags for different displays, like the display I'm using here has this problem. This clock phase one, basically what's on the very left will basically row 0 LEDs appears at row 63 and everything else is shifted one down, so it looks weird, but this fixes it. So yeah, so all I want to do now, so I have that set up, well, I nearly have it set up. Display setup. Okay, that should be that. Now I want to just display some color. I'll just throw these up here. They really should be higher up, but I'm super lazy. And I just want to set any text. That's all I want to do. Set a bit of text. I just want to see, is there a conflict between using the... You know, I really maybe should be doing this on the other example, the I2S mic test one. Because we could actually, you know, we could see that working. We don't know what the other one's doing yet. After it's been fast Fourier transformed or whatever. So let's, let me just do this super quickly. That's all this crap here. And we need the colors. DMA display. Can I do DMA display that color? Seeing as it's a null pointer. Doesn't feel like I should be able to. Was I doing that in the other stuff? Tetris, Wi-Fi Tetris clock. Yeah. It's my car alarm. Just does that every now and again, or else I'm getting robbed. I probably am getting robbed. At least I hope not. I use my black here. Where is that defined? Yeah, it's up the top. Okay. I think that works. Anyways, it must be a static or something. Okay. I probably need to text my wife or else she's going to try come in here. But the door's locked, so she won't be able to. Okay, I cannot see anything you are saying. That is okay, because you aren't saying anything, which is fine. Come for... yeah. In case my insurance company is watching, this is a joke, but I'd nearly be happy if my car was robbed. Let me just text Caroline. Okay. DMA display. Okay, yeah. Oh, yeah. Yeah. These should be pointers now. I should have changed the name of this, but anyways. So all we're hoping for here is some text on the display and the mic working the way it was before. It's okay. Yep. Oops. That would be ideal. So this is a small downside to the new way you initialize the library is you just have to update the I don't know, decimals, full stops to arrows. Okay, anything. That's all we want. Do not have high goals on this stream. Didn't I set up a web camera? Which one was that called? I don't see anything, but then again, I'm not powering the matrix, so that would probably help. I see something. All right. Is it this one? Yeah. So we got our hello. Okay, but now we need to see if we have our serial plotter. Do I have to close the serial monitor first? I don't see it there. Okay, serial plotter. Testing. 1, 2, 1, 2. Is it still working? Yep. Okay, it's still working. Oh, it turned into a square wave. Did I plug it out? Yes, I did. Okay. Awesome. Rotor, I knew you'd look it up. It seems to be working. Because this is working the same as it was before, and I've text on the display. So that's good. Right, so now we can just get onto the fast Fourier transform stuff. Right, so we've got 8. We have to do a little bit of maths here. We're gonna do a little bit of maths. So we have 8 of them. And we have 64 pixels, right? So 64 divided by 8 gives us 8. So we have 8 kind of to play around with. So we'll make them maybe If we did a 6 wide, we'd have 2 between each of them. That wouldn't be too bad. We could let's start with 4 wide. We'll pretty it up later. Okay. Okay, so I've pretty much the same code in this FFT one. And I've already fixed the arrows, have I? Yep. No, this is still I2S mic test. Oops. Yeah, let me just fix up this. We'll add the fancy stuff with the different colors in a minute, I guess. I don't know. In some amount of time in the future. Okay, cool. That's that done. Right, so we got our stuff, and let's create a new method, which is like draw. Wait. Draw. I don't know. I'm blanking with nice names. So draw on matrix. But we have some data. So we have an eye and a band. We just need to pass in the bands. The band's probably a global. Is it? Yeah. Bands is a global, so we don't need to pass in anything really. We'll need to do a 4. Okay, the first thing we'll need to do is make the matrix black. We will we'll definitely move to the double buffer, but just not yet. 32ch. What's that? 32ch? What? Yeah, what Rotor says. Yeah, I was kind of hoping that if this works really well, I might make an add-on shield, or an add-on slot. Do I have one here that demonstrates what I'm talking about? Yes, I do. So this is a different add-on for the Trinity, but I need oh, it's kind of dark. Yeah, so this is an SD card add-on for the Trinity that it's basically just the right format to go into the Trinity board, where you don't need to use any jumpers or whatever. It might be useful. I don't know. They're pretty simple boards. It seems like the microphone board is pretty simple too. It has exactly 3 components. Sorry, it has a microphone, a capacitor, and a resistor. So I feel like that might be something we could make a pin compatible version of. Alright, so we have our for loop. Okay, so we need to map. Do you guys ever use the map function? I've used it recently. Let me go on GitHub to find it, so I don't reveal code that I don't want to reveal. I2S matrix shield. Examples, LDR auto brightness. With two of the probably 2 of 3. So the map function in Arduino is pretty useful for this type of thing. Right, so they had, let's go back to his code, because he had an upper level of code. He had a max, didn't he? high value, whichever is the highest between 0 and, okay. So there isn't really a max. There's this max value. Where does that get used? Okay, let's just map stuff to that. Which is pretty big. I suppose we could do the color stuff pretty easily, but anyways. Right, that's our map max. Right, so sensor value is our input. So for us, that's going to be bands display. That's this. No, sorry, this is max input. Min input, it has to be 0, right? That's why I prefer to write 2E8 instead of the bazillion 2000s. Yeah, I don't know, I suppose. I don't know if it'll clamp that to 2000, but anyways. Right, so this is where we get to convert it back to something that we can actually use. So let's make it between 0 and 60. So what the map function will do is it'll take that number and basically get a percentage of these and then make it the same percentage of this. And that's what gets returned to you. Bar height equals map. So I think that should be it. Just need to look up filled rectangle. What's this thing called? Adafruit effect. Primitives. Filled rectangle. It starts at XY up the top. Okay. Right. Okay, so this is going to return us something. So say it's going to be like 30, right? And we want it to be down 30. Like we want it to start from the bottom, but where our rectangles draw from is the top left. So what we need to do is we need to take everything away from 64, I think. Right, so where's my fill rectangle? DMA display filled rectangle. Right, so our X, we'll need an X value. Int X is equal to I don't know. Just gonna do I by 8 for now. I'll do I by 6 for now. This won't look right, but we'll fix it up. So that means if it's 0, it'll start at 0. Let's offset it by 2, so it's not right up against the edge. I just prefer doing this, even though it should be implicit. So yeah, if I is 0, it'll be 0. If it's 1, it'll be offset by 6. If it's 2, it'll be offset by 12, etc. So that gives us our X value. So we can do X as that. Our width, I'm just going to say it's 4 at the moment. So our Y0, this is going to be 64 minus our bar height. So if the bar height was 30, I think that'll be right. Yeah, so the smaller the bar is, the further down it will be. Is bands really bigger than uint 16 to make it an int? Oh, because of this? This is just the... This is what Adafruit GFX uses. This isn't anything to do with me. Oh yeah, like we can work on that stuff. That's... We have to crawl before we can run. Like, as in... Like, what you'd really want to do is say, like, this width here should be based on how wide your screen is. And we do know that from this thing here now. Our width is 64 by the number of panels in our chain. So it is possible to do that, but I'm just going like, let's go super simple for now. Because if we can't get this working, there's no point having the logic of how the rest of it works. Right, so... Well, but if bands is just a uint 16, then 2e8. I don't know what bands is. What is bands? Bands is a regular int, apparently. Where am I? Here. H, just be bar height. Color, I'll use my green for the moment. Hey Alex, how's it going? I think that should cover us. Let's get rid of the serial print. I don't have anything set up for my own stream like that, Alex. Right. Let's build this. We taking bets. Is it going to work? Is it going to work? Let's see if it compiles first. Let's do that much. 4 beers and 2 whiskeys. Okay, so we can ask Alex all the questions now. He's got the truth serum. Is it me webcam? Me webcam? Not me webcam. Desk plus me. This one. So do you think it's going to work? Okay. Well, the first thing is it didn't compile. So we'll fix that. Okay, so I had just left this out. Okay, so let's see. Is it compiling now? Right, taking bets. Is it going to work? It's compiling. It's compiling. What is going to happen? What is going to happen? It still says hello. Serial monitor is not available while the plotter is open. Okay, let's get rid of the plotter, so. Let's reset this. So it didn't seem to work now, to be honest. Mic is set up, drivers installed. Well, I don't actually see it trying to do anything, so it would help if I called draw on matrix, I suppose. That would help immensely. So I made this nice method for doing things, and I did not call it. Good question, Rotor. Where do I call it? The answer is nowhere. Okay, that's fairly freaky, but it's probably doing something. Testing. It seems to be very fixed size, so I'm thinking I'm doing something wrong here. And that gap in the middle has me confused too. So let's take my logic and apply it to a new thing called Brian's bands. And okay, let's make this like what was the max? This seems very high, isn't it? Is this even has a peak hold? Ship it. Yeah, this is a new pattern that I've invented. It's called the brine bands. Did I definitely take the right value for that? Or is it squicks? No, squicks. Where is it? 20 million, is it? 1, 2, 3. So it's 200 million. Seems high. Anyways, which one is it? FFT ESP32. Right. So this is, yeah. Okay, that's right. Okay, so Brian's bands. Let's make the first one max. Next one, half of it. Next one, half of that again. Oh, interesting. Next one, half of that again, I guess. Next one, start to get down to numbers that are hard to figure out. It should be 1, 2, 5. Get rid of one of these zeros. Let's just leave zeros for them because I can't figure that out. I have 2 draw on matrix. That's fine. Brian's bands, draw on matrix. Brian. I'm gonna call that from here. So I'm just gonna put 1 in the setup. So we're gonna call and we'll see what it looks like. Who is, Scott. Oh yeah. Yeah, I didn't like really plan to stream, it just was the way it worked out. Okay, so I wasn't showing the code. Apologies. Right, so what I just did was I made a fake sample list called Brian's bands. Made them, so that's the max, that's half the max, that's half the max, so also a quarter. Yeah, and so on, and then I gave up towards the end. So I call in my setup this new method, draw on matrix Brian, which is half of everything. Okay. So they look broken. They're 4 wide, which is what we'd expect. Do I definitely have a 64 by 64? That is part of our problem. Let's fix that. So I was telling it was a 32 height matrix when it is a 64 height matrix. So I was kind of expecting that to be a problem when there was that gap in the middle. Sure, I can add this to... Okay, I think there's probably something wrong with my map, but we'll take a look at that now in a second. Let's add desk cam. Oops. Desk cam down here. Right. So as you can see, we've like a load of full bars, but then we also have this one down here, which is not a full bar. So it gives me hope that we can draw something on it. I don't even know why they're full bars. This should... Oh, well... No, I'd expect some of them to be empty. I'd expect some to be full and some to be empty. Like, okay, so we've 1, 2, 3, 4, 5, 6, 7, 8, right? Okay. So let's make sure I'm using map correctly, because I could be using it wrong. That should be the input, and that should be the input range, and that should be the output range, if I'm not mistaken. Arduino. Oh, I've left my window open and the moths are coming in. Right. Ow. Oh, my legs are so sore. Okay. Only required, please. Yeah, from low, from high, too low, too high. Right, so that's our input, bands. So that's correct. Can't be anything else. From low is 0 all the way to 28E2. Hey Dave, how's it going? I never use 28E2. The reason it is 64 minus that is because rectangles have to be drawn from the top, and we know the height of something, and yeah, 0, 0 is the top left of the matrix, so well, yeah, 64, yeah, so 64 is down the bottom, and then we're minusing the height of the thing, so that should bring us back up to like the wherever height it was, and then we're drawing it back down that height again. So that should be okay. Okay, so let's look back at the code, see if I'm doing anything else wrong. So fill rectangle. So let's look at our fill rec. Dave is a mod. He'll do anything. X, Y, 0Y, width, and height. And then color. But it's going to make it 4 as the smallest is not 0. Yeah, that's possibly true. But that's not the problem we're having, I would say. Like, it definitely could have, like, some problems, but it shouldn't be, like, 7 of them being full height. So, yeah, I think serial printing out the calculation probably makes sense. I don't think I actually need to do that, but I'll do this anyway. Serial. So, let's serial print out the bands, except I don't need to do, yeah, band I, comma, let's do a serial print lin bar height. I don't know why he has that in a string, not needed. except I don't really want to do it in draw and matrix. I want to do it in here. Okay, let's upload to this. The mighty wrench has appeared. Right, so I'm just printing out the calculations now, what the input is and what the output of the map. So that will hopefully reveal some secrets. A lot of minus values. Why is there so many different values? Oh, hold on. Bands and brine bands. Yeah, I'm not actually using the 2E8 thing at all, so at the moment. Oh yeah, just so you know, Makercast is on this Sunday on Intermittent Tech's channel, or Intermittent Tech. So make sure you check it out. I'm sure everybody here already knows, but okay. Okay, so we've definitely messed something up here, because that's come out as -3. Is it not, oh, it's probably not big enough to hold the output, is it? But it's just it's an array of ints, right? Bands is an array of ints. Link Makercast. Dave, are you in a position to do that, or do you need me to? Tiny LED Matrix, you are a moderator. Please link if you can. The map, there has to be something weird with the map function, right? So let's go back to the serial monitor again for a second. Sorry for all the jumping around. So this is what we have going in. No mod, you are a mod now. You are. So this is what's going in. And this is what's coming out, but it comes out as weird numbers, like, what is happening? Where are you? Like, it comes out as -3. Stop doing silly maps, but maps are lovely. It's what, like percentages? But I feel like that's just what a map does. So map uses long data type. Okay, so it's not. Oh, so I should be. That's true. I could do that, but is there a low? Like, what is? Yeah, the lower range is also absolutely massive. Yeah, sure, I could do what Sion is saying and just divide it by, like, what's that low number there? 2, 0, 0, 0, 0, 0, 0. How many zeros is that? 1, 2, 3, 4, 5, 6, 7. Right, so I could divide by like 6. I could divide by 1,000,000, I'd say. And we'd still be in fairly decent shape, I think. And is this a log scale as well? No, it goes up pretty steadily. Okay, good suggestion. Let's divide by 1,000,000 and see what happens. Fast Fourier, right. So Brian's bands. One, 2, 3, 4, 5, 6. Right, there's my 1,000,000. But now the max number will be 1. Get rid of how many of these? One E6. Yeah, it's true. Right, so 200 is now my max. Okay, I can work with that. That should still map. Did you get it? Map. 1E6. Divide it beforehand, serial print. But yeah, we'll see anyways. It'll serial print the old number, but like that's what it was to begin with. Okay. Good news. Some things have changed, but I'm still confused to why they have changed in this order. Okay, that's what we'd expect. That's what we'd expect. This is not what we'd expect, but maybe it is. Maybe I calculated how many zeros there are wrong. Because that seems to be like if 2 is 60, then 4 would be 120 and 5 would be 150. So I seem to have the wrong amount of zeros. I don't think that matters. I think this is wrong, and this is what Rotor was. No serial print. Do you know how much serial prints cost? I think Rotor was probably right with the number of digits we have is just nuts. It is. You got too many zeros. I'm back. We've loads of progress, Johnny. You'll be so proud of us. You won't believe the amount of progress we've had. Well, I mean, there is some progress. Boom. Zeros are being treated as like some crazy number, but other than that, why is it doing that? Unexpected spam. I'd say he's probably getting rate limited by YouTube. Never mind you. Oh, okay, 0 from 0 leaves 0 minus 64 gives you 64. It should be 0 wide then. The bar height should be 0. So where it's getting its height from, I don't know. I guess if bar height is 0, it should just be like don't draw anything, right? Okay, so if we fix this like we think we have, let's just change this to 200. Should probably leave ourselves a comment here that map didn't seem to like these huge numbers. But it's not 64. It starts at 60. 64. It does start at 63. I still don't know, like, there must be a bug in Adafruit GFX if you draw a 0. Like, that should be drawn as 0 height square, which should draw nothing. But if you draw 0, maybe it defaults to like the full height. I would think that's a bug, but it's not for me to say. It's also stupid what we're doing. So I wouldn't go raising a pull request about it. If bar height equals 0 or not equal to 0, do this, and if it isn't, do whatever. So I think this updates so often. I think this updates so often that it's going to be I think this updates so often this is going to be like not good. The double buffer will probably help with that, but I think it's going to be like flickery as all hell. Like, let's see. Did I fix everything that I meant to fix there? Yes, yes, yes. It's probably convenient to bring that down, but we don't need it right now. Any occasion, Alex, or just Friday for the drunkenness? All right, that's something. Testing. Oh no, I plugged out the thing, did I? Yeah, this is dodgy. Should like glue it in or something. Testing. No, what's going on? Go over the top, maybe. It's kind of got a cool effect here. Ah, what is going on here? These Trinity boards are shoddy. Testing, testing, 1, 2. There's something to clip this on to the Trinity board, or to, this might work. Oh, excuse me. No, perfect. Not perfect. Testing, testing, 1, 2. Why have you gone away? I guess I should draw something if there's nothing, like even if it's 1. Because it looks real lonely. Testing, testing, 1, 2. Get up here. Yeah, okay, I'm definitely going to draw something. If bar height right, I suppose I could do it here. If bar height is equal to 0, bar height equals 1. That's pretty significant, but anyways, let's give it something. Okay, DMA display, expert height. Okay, that's fine. I think we'll need to implement the double buffer. It won't take us long to do it all, so let's just do that. So like all we need to do to implement it is set this to true, and then we do, what do? We do, I forget how to do the double buffer. Where is it? Yeah, flip DMA buffer. Let's fill the screen to black. Flip DMA buffer. Set text wrap, that should be fine. Do that and then show DMA buffer. This will get replaced pretty much immediately anyways. We can get rid of our draw on matrix brine for the moment. We flip the DMA buffer. What are you looking at the moment? Yeah, that's fine. Flip the DMA buffer and then show DMA buffer. I'm still not sure if I can write the display fast enough, but we'll see. Make it white if it was 0 and green if it's actually 1. That's a good idea. I like that idea. Okay, so it's at, I don't know, can you see that? It's all green at the moment. Let's get that red cable out of your way. Okay, so testing. Have we clamped it too much? Okay, no, it's doing something. It's still not that good in terms of like it doesn't stay on screen very long. I guess that's where you could have kind of the fading back down thing, but I don't know. Let's get some copyrights going here. Copyright free music. What I really should be doing is going to what's your man's name again? Kevin MacLeod. Kevin MacLeod. Alright, Kevin. You've like, no, it's not a MacLeod, is it? Yeah, Kevin MacLeod, not Kevin MacLeod. Incompetech. I don't really want to search for anything. Can you just show me some music? Incompetech. Alright, so this is all from Incompetech. Okay, let's play this here. It's coming from a sneaky snitch. Okay, so it seems to do something, but I think it's updating the display too often. So I might put in an artificial like slowdown. In the code, so I'm just going to delay it by 10. That should mean it updates the display less often, so it does less processing of what's on the microphone. But like that should be fine. Maybe I don't know. Like maybe 10 is too big of a delay. It's 10 milliseconds, like it's not a lot. Hey, Simple Electronics, how's it going? Yeah, slow refresh rate. So, like, I guess you could take more data and average it. It's still pretty... We just get it to tell the future. I guess the other thing that's possible as well is we can offload it to the second core. The high isn't right. It's registering a little bit, but the equalizers do tend to look like that though, don't they? Maybe not delay, sample less. Like up on the I2S like config stuff. That's probably something I need to look at. See you, Rotor. Night. Not a lot of bass going on right now. Yeah, I guess. So you can find a more bassy song and see how that responds to it. Funk, cinematic. Can I search for him? Genre, drum and bass. That's surely got to have bass in it, right? Search now. Drum catcher. Yes. It's doing something. In the draw function, pull a figure less frequently and draw it for longer. Well, that'll effectively work the same way as the delay, right? Where you might be sampling. Yeah, well, like that's my phone. Speaker. So like just delaying what you draw on the screen. Well, I don't really know how the I2S stuff works. Yeah, I haven't done anything, like as in I just took whatever example code there was and did that. Ocean. Hey Graham, if I didn't say hey. Yeah, I don't know. We're getting somewhere. but it's a bit all over the place. But like, it couldn't be worse than... Well, we never actually saw this working. We're just going... also, that seems to decay. See you, Anthony. Take it easy. At the moment, it's every 10 milliseconds plus however long it takes to do other stuff. So it's effectively every 10 milliseconds. But if, like, I probably need to look how I2S works. But, like, say there isn't any point calculating the fast Fourier transforms and stuff. Maybe, is that the problem, that we're not decaying? Yeah, like, I'm not doing anything at the moment, and this thing is... powering the mic from a different voltage source. It's 3.3 only, so, like, the only thing I'd really be able to power it off is another dev board. Yeah, like, there's a lot of noise on it now. Like, I'm quiet and it's still doing something. It nearly seems the more I make noise, the less it displays. Battery. Like a coin cell or something. I could power the matrix off a power bank. Or some other dev board off a power bank. Yeah, it's way too noisy at the moment anyways. Do I have any ferrite beads? Not loose ones, I'm sure. I have some attached to some cables, but nothing loose. I could... I don't have, like... I don't have that kind of... I don't have that kind of, like, input to whatever I'm doing, I don't think, Frank. Like, there is some mention of, like, a filter here if VReal is at a cruised noise filter 10x amplitude or more. But, like, I don't get to set, like, the dB levels, I don't think. Or maybe I do, I just don't know where to do it. Yeah, it's something, but yeah, it's definitely jumping all over the place when it shouldn't be. Let me power it. Let me just turn off my camera. Yeah, but if it's being noisy with silence. Okay, so this is interesting. It's plugged into my power bank at the moment now. And we have nothing. And after picking up a microphone. Nothing. Oops. Testing. Well, that's interesting, isn't it? Why did it stop working when I plugged it into a power bank? That's confusing me. No, why? Why has it stopped working? Okay, I think we might leave it there, and this is something that we can revisit some other time. Yeah, even tapping on the mic isn't doing anything. Nothing. Nothing. Let me just plug it back into my PC and see it going noisy again. No, what's happening with this? No. I'm more curious than anything. Power Up by Jeremy Blake. Oh, how's it? I think. Okay, so it's there. So why isn't it displaying anything? Mic is... Did I update the mic values in this? I did, yeah. Configuring the I2S. Does this one use the right port? I2S number 0, what? What did Router say? Writer say? Earlier, he said... I can't scroll up far enough. Oh, he does. While the mic in this example uses number 1. Alright, so this is... Or number 0. Okay, so that's fine. See, is there anything different between these two mic examples? Oh, channel format, only left, only right. That could be a problem. Let me take this example. Don't mess around with this, okay. because we know this example's working for us because it displays pretty well. So let's take this example and take all this stuff. Back down to the bottom. Power up. Oh, power up is Bitlooney's music, is it? I feel like Bitlooney would copyright strike me if I what is this now? Can I just get rid of this? If where's this? Does this driver install happen anywhere else? Yeah, it does. It just doesn't do anything with the response. Boom, 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 boom. Hey, Intermittent Tech, how's it going? Oh, yeah. 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 Oh, baby, look at this. This is way better. This calls for some Power Up by Jeremy Blake. Ah, yeah. Does seem to be a little bit slow. Or maybe it is on the stream. It's just like, if a song doesn't remind me of Bitlooney, I don't know what does. Like, feels wrong, but it feels so right. I think this is a good way to end the stream, playing Bitlooney music. Oh, actually, I'm gonna start my own gimmicks as well. Bitlooney can have his fondue cam. I'll have my raclette cam, and I'll power it using my little whatever that thing was called, the miniware thing. Look at this bad boy. Could do some real dangers with this. Creating the next Bitlooney intro. Yeah. The high end is responding now. It probably helps that we have like set it to use the channel that the mic was set to. So that probably helped immensely. Yeah, okay, I think we should call it a day on this one. It's 12:30 at night. I need to go to bed. This is a pretty good point here. It's got something going up and down. It's not very responsive, but it's doing something. So yeah, I think this will probably be a decent candidate for like moving stuff to. It still is the 10 millisecond delay, I think. Doesn't it? No, it doesn't. When did I get rid of that? No, it doesn't have a 10 millisecond delay. No. It does not. Where is that 10 millisecond delay gone? Okay, but that's fine. It's still not very responsive. That's a little bit. No, it's not. But what we'll probably do is we'll move either the FFT code or the matrix code to the second core and see how that goes, but that's for another day. Yeah, so I will see you all later. Thanks for watching, and I'll catch you again for more adventures into getting this equalizer working and looking nice and all that good stuff. Right, cheerio. Now I do the awkward dance of finding how to turn off my stream. Okay, bye. I'll see you next time. Bye. Oh, hi Tobias. Bye Tobias.